Welcome to this presentation on Eurocode 6, brought to you by Eurocode6.org. My name is John Roberts and I'm going to guide you through this presentation. Eurocode 6 is published by BSI as BSEN 1996 and deals with the design of masonry structures, relates to buildings and other civil engineering works and covers reinforced, pre-stressed and confined masonry. Part 1.1 covers the rules for reinforced and unreinforced masonry. Part 1.2 deals with structural fire design. Part 2 includes design considerations, selection of materials and execution of masonry. And Part 3 deals with simplified calculation methods for unreinforced masonry structures. Each of these parts has a corresponding UK national annex, which is published separately. There are many different types of masonry unit used across Europe with local traditions of materials and methods of construction. Here are some of the typical European bricks. Eurocode 6 has a number of rules which take into account these differences. In the UK, there have been a number of innovations with clay bricks over the years, but the brick is now primarily defined by its size, although there are a number of special bricks used to assist with architectural detail. There are also many types, sizes and configurations of concrete masonry unit. Here, two core hollow blocks are being laid using shell bedding in which the mortar joint is not continuous through the thickness of the wall. Design information is provided in Eurocode 6 for this form of construction, although in the UK, masonry is invariably laid with a full bed of mortar. In parts of Europe, it is not usual to fill the vertical perpen joint with mortar, and this is reflected in some of the limiting values in the code. There are 6 masonry unit standards numbered EN 771 1 to 6. These cover clay, calcium silicate, aggregate concrete, autoclaved aerated concrete, manufactured stone and natural stone masonry units. Note that in Eurocode 6 there are only references to masonry units and terms such as brick and block are not used. The masonry unit standards all provide detailed information which the manufacturer will provide in the declaration of performance for a particular masonry unit. The declaration gives key information including dimensions, strength and configuration. In addition, it is possible to specify tighter dimensional tolerances when units are required for applications such as thin joint masonry. Around 80% of the mortar used in the UK is factory or semi-factory produced, and mortar for masonry construction is covered by EN 998 Part 2. EN 998 Part 1 deals with mortar for renders. Factory produced mortars includes various bagged products mixed on site, as well as ready-mix retarded mortars which can often have a useful life of 3 days. Many sites now use factory produced mortar from a silo. Where mortars are mixed from the individual constituents on site, they are not covered by EN 9982, although the individual constituents comply with the relevant standards. Site mixed mortars are usually tested using the same test methods as those developed for factory produced mortars. Mortars are specified by compressive strength class. For example, an M4 mortar would be expected to have a strength of 4 newtons per millimeter squared. A mortar designed to meet a strength class is different to a mortar specified by mixed proportions, and table NA2 from the UK National Annex to BSEN 1996-11 provides the assumed equivalence. In common with the other material Eurocodes, EN 1996-11 follows a standard arrangement of sections: general, basis of design, materials, durability, structural analysis, ultimate limit state, serviceability limit state, and detailing. There are also a number of annexes, and in the case of Part 1.1, all of these annexes may be used in the UK. So, for example, Annex A gives extra information relating to execution and the relevant partial factors, whereas working our way through, Annex E gives us the bending moment coefficients we will require for laterally loaded wall design. Annex F gives us the limiting values for our laterally loaded wall panels, whilst the last annex, Annex J, gives us some enhanced values for reinforced masonry elements subjected to shear loading. There are a number of definitions of terms which are not common in the UK. Confined masonry is masonry provided with reinforced concrete or reinforced masonry confining elements in the vertical and horizontal direction. These may be columns and beams. This is used to improve seismic resistance. We've already learned that a masonry unit is a preformed component which is used in masonry construction. To separate out different types of masonry unit, they are organized as 4 groups. These group designations for the masonry units vary with the percentage, size and orientation of holes in the units when they're laid. The requirements for these 4 groups are given in Table 3.1 of the Eurocode and allow for the wide range of European units. The masonry unit manufacturer will usually declare which group a particular unit belongs to. In the UK, we are used to using solid, cellular and hollow units. All these units are covered by Group 1 and Group 2, and there's no historic experience of using Group 3 or Group 4 units in the UK. Another important aspect of structural design is the normalized compressive strength of a masonry unit. This is obtained by taking the compressive strength of the unit tested as a whole unit in the normal way, converting it to air dried, and then converting it to be equivalent to the compressive strength of a 100 millimeter wide by 100 millimeter high masonry unit. By normalizing unit strengths in this way, the resultant design is independent of the shape of the masonry unit, and any masonry unit may be used providing the normalized strength requirement is met. The characteristic compressive strength of masonry may always be determined by testing in accordance with EN 1052 Part 1. In addition, the UK has used its historic database to provide, in the National Annex, the values that may be used in conjunction with Equation 3.1 of Eurocode 6. To determine the characteristic compressive strength of masonry in accordance with 1052 Part 1, wallet specimens are used. To determine the compressive strength of masonry units, whole masonry units are used, although the method of preparation and conditioning is material dependent. Equation 3.1 enables the characteristic compressive strength of masonry to be calculated using the values provided in the National Annex. Fk is the characteristic compressive strength of the masonry in newtons per millimeter squared. K is a constant, alpha and beta are constants, FB is the normalized mean compressive strength of the units in newtons per millimeter squared, and FM is the compressive strength of the mortar in newtons per millimeter squared. For the flexural strength of masonry, FXK1 is the characteristic flexural strength parallel to the bed joints, and FXK2 is the characteristic flexural strength perpendicular to the bed joints. The values for use in the UK are shown in the National Annex. Annex E of the Eurocode provides the bending moment coefficients required for flexural design, and Annex F of the Eurocode the limiting dimensions. The model for assessing the eccentricity of vertical loads in the Eurocodes is based on a frame analysis. The wall is assumed to carry moment at the top and bottom. An initial, sometimes known as an accidental eccentricity, equivalent to the effective height of the wall over 450, is applied to the full height of the wall, along with additional allowances for creep and the second order effects which are covered in Annex G of the Eurocode. Section NA3 of the UK National Annex indicates that all the informative annex if Part 1.1 may be used in the UK. In addition, additional information is provided in the note to help with the design of timber floors. The final part of the UK National Annex, NA4, gives us references to non-contradictory complementary information, or NCCIs. There are a number of these. That completes this introduction to BSEN 1996-11, brought to you by Eurocode6.org. Visit the website for more information and NCCI guidance documents. Thank you for listening.